In this video, we are going to learn gateway offloading pattern. Gateway offloading pattern offers to combine commonly used shared functionalities into a gateway proxy services. By this way, these shared functionalities can application development by moving shared services functionality into centralized places. In microservices, we can give example of commonly used shared functionalities are cross-cutting concerns, which are the authentication, authorization, rate limiting, SSL certification, logging, monitoring, load balancing, and so on. So implementing all these cross-cutting concerns for every microservices is not a good solution. It is good to assign these cross-cutting concern tasks into centralized places. Gateway offloading pattern offers to manage all those cross-cutting concerns into API gateways, because these features requires configuration, management, and maintenance. So if you try to distribute all those functions for every microservices, it is increase the deployment problems and the administrative overhead. So implementing gateway offloading pattern gives us to simplify the development of microservices by removing the cross-cutting concerns on services to maintain supporting resources, and allows to focus on the application functionality, leaving these cross-cutting concerns to the API gateway experts. Now let's look at the image on the slide. If we wouldn't put the aggregating and offloading pattern in here, the client application and every microservices should be responsible of authorization, authentication, certification, rate limiting, and so on. In order to solve all these problems, we can use gateway offloading pattern to reduce duplicated code for cross-cutting concerns in the microservices. You can see the image. This pattern implements all cross-cutting concerns and makes microservices simple and task-focused development services. By this way, we can improve the application performance over the high latency network. But we should be careful when implementing this pattern. There are some issues and considerations using the gateway offloading pattern. We should ensure the gateway is highly available and resilient to failures, and we should avoid the single point of failure by running multiple instances of API gateways. And also, API gateway is designed for the capacity and scaling requirements of our application, and it should be covered our application requirements. And we should make sure the gateway doesn't become a bottleneck for the application and it is sufficient scalability.